Log on, tune in, find out. Another good idea from Cambridge.
To the discussion session in today's meeting, and the plan is for it to be a discussion, yes, involving and to some extent led by our panel members here, but also very much drawing on the kind of lively activity we've had from the floor today. So I hope everyone will join in. Our panellists, the first two, of course, you've already seen quite a bit of, Tim Davis and Martin Owen, who've got a wealth of experience here from different industrial sectors. We're also really pleased to have Claire Tansley there, who works for the Engineering and Physical Sciences Research Council, and she was formerly working on business engagement, but has recently moved across and is now a senior manager for the Mathematical Sciences programme, which includes, of course, statistics. It's also, we're very lucky to have Robert Lees here. And Robert is a director of the Knowledge Transfer Network, yes, for industrial mathematics, and that includes also statistics. And so these two panellists are very well placed to tell us about ways of working and opportunities within their remits, and in some cases with the possibility of supporting funding. Our two academic representatives on the panel are Professor Henry Wynne, who's of course very well known, not just as an expert in design of experiments, but also in risk generally.
Well, jokes. I'm well known.
He's also quite good at jokes, yes. And finally, we've seen rather a lot of the last one today, Dave Woods, who's a reader in statistics at Southampton. And both Dave and Henry have got quite a bit of experience between them in actually working with industry in various modes. Okay, so the idea in this session is to draw together discussion thinking about the advantages of collaborations between industry and academia and how they can work, how they can come to pass and then go on and hopefully be successful in practice. Some of the difficulties you can encounter and perhaps drawing on people's experience of how to overcome them. And of course feeding in some of the ideas and the common themes that have come through already today. We hope that there'll be other topics, ideas coming from everybody here. So without more ado, let me pass on to our first panellist. What we've asked each panellist to do is to just spend 5 minutes, and I'm going to be very strict on this, just explaining a little bit about themselves. I promise I won't call up the 5-minute one, that would be cruel right now, but we've got a 1-minute one. So after each of the panellists has talked very briefly, then we'll throw the floor open for discussion amongst everybody. So thank you, Tim.
Am I going first? It looks like I can't remember what I wrote. I had to stand up to read it. My eyesight is good enough to read. So Dave asked me to, I think he's asked all of us. I've only provided one slide. I think the instruction was 3, but I knew there would be a 5-minute limit. So if I had 3 slides, I definitely would make it. So this is my personal perspective. Whether my personal perspective is scalable to a large number of people, I don't know, but maybe that might be part of the discussion. What are the advantages, first of all, of a collaboration between industry and academia? And I think the advantages are that essentially the problems are understood in context. That to my mind, would be the major advantage. When I started my career working for the Dunlop Tyre Company in Birmingham, we had a really serious problem in competing risks that we didn't understand. There was a lot of, when I went to join Dunlop directly after graduating with a reasonable degree in statistics in 1981, there was all this data on tyre failures that had a lot of competing risk aspects to it, and nobody really understood it. So I literally picked up the phone to the University of Birmingham, which was the nearest university to the factory, and John Copas answered the phone, I think. He was the head of department at the time. And the next thing I knew, I was enrolled to do a higher degree. I should say, by the way, that I had very good support from my then boss at Dunlop, who had also done his PhD part-time. So essentially, I embarked on my PhD research while I was employed at Dunlop. I had a lucky experience. I went to Japan, actually, to try out the theory. I did some work on how to develop tests, and a Japanese company that was associated with Dunlop had a problem with understanding the failure of a particular tie they had in the market in Japan. I went to Japan to try out some of my research, and luckily it worked. So I got a ticket to come home. And Tony, I don't want to be all soppy here, but Tony Lawrence, my PhD supervisor, has been a dear friend ever since. So it was a good job that Tony and I got on, because I was bugging him for 8 years. And but Tony and I have been very good friends ever since, and that's been really important for me, because whenever I've felt that I needed some sort of academic advice on various statistical things, I can always pick up the phone to Tony, and if he hasn't got the time to I've spelled his name wrong there, actually, don't tell him that. I think that's probably the spell checker that did that. I've always been able to pick up the phone to Tony, and essentially, he's often pointed me ever since if I needed help, so that's been really important. And then, of course, the academic development of the student, which in this case was me. All of my published work contains original data, which I'm very pleased about. Apart from the cherry tree data, I almost never analyse other people's data. The cherry tree is a big exception. And I even made and flew with help the helicopters that I talked about today. As I think I said, I rounded up some students at Warwick to do that. In terms of modes of collaboration, well, again, I'm coming at this from my own personal experience, but my sort of thought would be that the student being employed by the industrial partner is important. I mean, the Australians would say there you have skin in the game. I was employed by Dunlop, as I mentioned, and then subsequently the Ford Motor Company. And I think why that was important was, yes, I had some academic pressure to get some work done and so on, but I was also accountable to my boss for deliverables. So, obviously there was a business pressure on making sure that the work that I was doing was focused and timely and so on. And that I felt was very important. What are the barriers to success? Well, given that it took 8 years, I'm saying it's not quick. So it's really not for the faint-hearted in that sense. Now, if I'd have known it was going to take me 8 years before I started, would I have done it? I'm not sure. It's one of those things that once you start, it's quicker to keep going than to turn around and go back, I guess. But it's not quick. And it's more of a test of perseverance, really. But the thing that I got out of it primarily was that I learned how to think and I learned how to write. Those are the two most useful things I got out of my PhD. So that's what I wanted to say about it.
Okay, so I'd like to talk about the things that I think we get out of the industrial academic collaboration. Is it allows us to make sense of the bigger picture. So, you can look at a tree and you can see, there's some big branches, and then there's the fine detail in the twigs at the end of it. And it's all about trying to make sense, about looking at how everything starts to fit together. And if you look at the talks we've had today, you can begin to see there's some common themes emerging. And for me, that's the powerful thing about today, for example. You can see that people are very, very interested in looking at economical designs and impactful designs, and looking at how they can apply these to add value in their particular types of organisations. So it's all about making sense and looking at when the appropriate design should be made, should be done. Okay. The second part of it is the mindfulness, and I think this is something that Dave and I feel very passionate about, is that when people do experimental designs, to be thinking about what the consequences of those designs, that you have choices all the time when you're doing designs. How many experiments you're going to do, what are the factors, what range you're going to look at. And it's about understanding what it is that you're doing and thinking about that. So, for example, it's more like cooking than following specific recipes. What we want to do is get people to think about why they're doing it, and being aware of the consequences. So if they are prepared to do less experimentation? What are the risks associated with that? What are the downstream implications? Can they afford to take that risk now? Or can they afford to actually invest now in these experimentation? Does it make sense to defer that risk till later? So that's all, I think, what this academic industrial collaboration is all about. It's about helping us make better sense of the world and actually be more aware of the consequences of our decisions. In terms of collaboration, the question was along the lines of what are the modes of collaboration. I think we've been very active in two main areas. One is with research collaborations, and so we've done a number of things with Southampton University in particular. I mean, we do GSK deal with all sorts of collaborations, but I'm specifically talking about ones that I've been involved in myself. We've had ones on supersaturated designs, on closed loop optimizations, on kinetic designs, and we're just about to embark on very excited that we've managed to get funding for a 2-year postdoc down at Southampton University to actually look at sequential experimental designs and very much this idea of how everything starts to fit in together and how things are organised. Why is collaboration so important? It's because, if you think about the skills that I have, I look at the bigger picture, I look at, how we can do the application, but, what I'm not, what I don't have is the time and the intellectual capacity to do what these folks at Southampton, or indeed many of the people in the room, do, which is that deep analytical statistical processing. I'm not capable of doing that. But what I can do is work with people who are, and that's the real importance of team working, to actually think about how you actually bring all these talents together. And then finally, I can't remember what. Right, so barriers to success. That's right. The real barriers to success, I think, is not necessarily technological hurdles. It's about organisational development. It's about how you spread these ideas, how you get people enthused and willing to uptake on these ideas, so that they actually own them and are empowered to actually implement themselves. So, as I've talked about all day, really, it's not the idea itself isn't the important thing. It's about how you actually translate that idea to a point where it adds value.
Okay, thank you.
Okay. So first of all, we're talking about academic industry collaboration here, but I also noted throughout the day there's been a lot of talk about collaboration with other disciplines, and I think that's equally important for this particular topic, and something that obviously PSRC is very keen to promote. Dave suggested that I talk about how EPSRC can help and facilitate collaboration, and if I went through every single scheme, every way we do it, we'd be here till midnight and we'd all be extremely bored. But these are some of the ways we support collaboration, some of the schemes we have. You can split it into 3 overlapping areas: research projects, specific support for knowledge transfer, so once research has been done, how do you then transfer that knowledge, and then training, which of course research is a very important element of that. For EPSRC, you can be a project partner on any EPSRC research grant. There's no upper limits, no lower limits in terms of the collaboration can be cash, it can be in kind. The only rule is we can only support people in universities, we can't support companies. So it's very, very flexible, and there's all sorts of interesting ways you can use that. Now when people put in research grants, they're required to think about the importance of the research and also the impact of the research and how they'll make sure that research gets taken up. And so some of the ideas, and this is straight from our website, for people to make sure their research can be taken up by either by other disciplines or by industry is, for example, secondments, people exchange. We've already heard one example of that. People's time, particularly allocated to thinking about working with industry, training, marketing or commercialisation time, workshops, seminars, all these sorts of things tied to a research project. EPSRC, because we realise how important it is for academia to be working with industry, we actually talk to companies ourselves, and we have quite a close relationship with about 29 companies that we call our strategic partners. And with some of these companies, we've joint funded research projects, we've set up research collaborations. And we ask them, what are the most important things you've learnt from collaborating with academia? And so these are the four main points that came up. First of all, close engagement between the partners right from the start of the project. So as people have mentioned today already, it's about talking the same language, about having the same expectations, about really getting on the same page right at the start of the project. And also from the point of view of the company, making sure the research done is actually the research they need, and really will feed into what's needed. Making sure expectations, not just in terms of the research, but in terms of publications and how the project will actually work in practice. Right at the start of the relationship is important just because it is a relationship, so it's got to run smoothly. People need to know where they stand. It takes quite a lot of time to do collaboration well. People have got from both parties. So people really got to put the time in to make sure that things run smoothly, that they're getting at what they want. But if people are willing to invest that time, and there's all sorts of benefits, and some of these have been mentioned already by the speakers, so it can lead to new connections, it can lead to leverage of science and funding. So although we don't fund companies directly, they can benefit from the money we put into universities. Industrial partners have said it can help to change academic culture as well, change how people think about approaching their research, and putting all the ideas together can lead to all sorts of new concepts and ideas.
Thank you.
Well, thank you. My name is Robert Williams. I'm Director of the Industrial Mathematics Knowledge Transfer Network. If you want a full lowdown on what we do, please follow our website. The Knowledge Transfer Networks, there are 15 of them in all, are a programme of the Technology Strategy Board, which is, if you like, a sort of business-facing analogue of the Research Councils. They're a government agency. And the KTNs, the Knowledge Transfer Networks, are very much part of the TSB's overall strategy. What they aim to do really is to catalyse interactions across, well, not just across the academic industry interface, in some areas also between industries and cross disciplines too. And to give you some idea of scope, we have about 2,000 individuals with whom we're in regular contact. Much of that happens electronically through the web portal. They represent about 400 companies, 400 organisations in total, including companies, universities, about 50 universities, and also public sector organisations also. In order to animate all these connections and links, we have a group of staff we call technology translators. It's not a phrase that we invented, it was invented I think in a previous government scheme about a decade ago, but we so liked it that we kept it. They essentially increase the density of connections by spotting opportunities and putting people together in combinations that we think will be effective. It's one of the reasons why we're involved in these Open for Business events with the Newton Institute, because we're excited about the way that they bring people together who might not otherwise get a chance to sit down and explore areas of common interest. In a wider scope, we're trying to sharpen industrial capabilities through the wider use of mathematics. I guess if we were going to put together a strategy for industrial academic collaboration, we'd want to keep it quite simple. And in many ways, building these sorts of relationships is very much like building any other sort of relationship. You've got to spend some time together. number one. You've got to try to understand each other, and you've got to make some sort of commitment. Okay? I think we've seen that in the previous speaker's statements. But essentially, if you've not got those three things, you've probably not got the makings of a decent collaboration. And those will need to be part of what goes on. When times are challenging, perhaps got some other things that you've got to think around. I'm thinking about economic challenges. And if you read the news the last 24 hours, it's going to be challenging for quite some time. I think helping each other becomes even more important. I think if you can find areas where you can collaborate and both solve some challenge that you've got, that's highly attractive when resources are thin on the ground. You've got to recognise that maybe it's not just enough to find common interests, but to find common priorities. Maybe you've got to look a little bit harder to find where the best opportunities lie. But also there are opportunities, I think, when the world is changing and when it's not just business as usual, there are times and opportunities then to find ways of doing things differently, maybe to explore some new avenues. And I think looking at in an area where we work like mathematics, there's so much, it's so versatile that there's always the opportunity to try something new. So I think there's especially in an area such as the one that we're operating in, there's a lot of opportunity going to come out of really what's just a shake-up of the whole business landscape. I thought what I'd do is just to close by showing you some examples of a particular mechanism that we've got. This is something that we've put together. We designed it in collaboration with our industrial colleagues and our academic colleagues, and EPSRC and the Technology Strategy Board have been helping to fund these projects. These are additional elements in PhD training. So the idea is that a current PhD student takes some time away from their host institution and goes to work in a company for between 3 and 6 months on a project that is mutually agreed in advance. And this isn't a replacement for existing PhD funding, it's an additional element. And what happens is that you can build new relationships doing that. Very often the student goes and works on a problem that they've not been directly exposed to at all in the past. And hopefully the way that they've been, Tim mentioned learning how to think. If you've got a good PhD student who learns how to think, they can turn their mind quickly to all sorts of interesting problems. And the diversity is huge. So just to go round there from, if I go clockwise from top left there very briefly, that first image is modelling of diving boards. This is looking at this was done with British swimming in preparation for the next Olympics, essentially, looking at the ways that you should coach divers to make best use of the mechanical properties of springboards in particular. The middle on the top row, looks like the inside of a cathedral. That was with Arup, the consulting engineers. They wanted to develop techniques for artificially lighting designs. So when you look at building design, when you build virtual models of new buildings, you want to know what the interior is going to look like in different lighting conditions at different times of day. To do that quickly and effectively was the challenge there. Top right, that's perhaps a bit closer to home. That's Shell and the statisticians in Durham looking at reliability and maintenance planning for offshore equipment. Bottom right, the train, that was with British Telecom, BT. Trains don't keep their timetables, and so if you're planning a journey, it's good to know to be able to build in the uncertainties that are inherent in the timetables. In fact, what they've done is go and harvest data off live arrival and departure boards, so you know so you can get very good fits for what the delay distributions are on each segment of track. Then you can come up with a more informed, shall I say, planning tool for passengers, which takes into account the delay distributions on each leg of the journey, and not just what the timetable says the train should be doing. Middle at the bottom, National Grid, looking at vulnerabilities in the transmission network in the UK, especially in light of increasing elements of renewable generation on the grid, and that will introduce vulnerabilities into the transmission network that need to be understood. And I guess you're all wondering what the last one is. That is looking at microbial ecology in underarm environments, with Unilever. Now, there's a huge modelling issue there, and there is indeed an experimental element to all of this, and through the people that you've had who are rejoicing the job title of underarm sniff assessors, and they go about their work and produce data, I imagine, that can do experiments. Looking at DNA sequencing of the bacteria that live in such places, and boosting that up to a larger scale ecological model of what's going on, that turned out to be extremely challenging. Anyway, there's a huge diversity. I'd be happy to explain a bit more about that, but I thought it'd be useful to just show you one concrete example of a mechanism that seems to be filling a gap over quite a broad spectrum of areas.
Thank you.
Well, thank you very much for. I'm honoured to be in such company. And I hope that Robert gives plenty of money to statistics. It's a big show a little bit. It's an old joke, that one.
Of course.
So maybe we'll discuss that over a drink. I didn't read the pro forma as well as I should, but I've read it since, and so what I've done is I've done something a little bit futuristic, but I want to weave in the 3 points, the opportunities, modes and barriers while I'm talking, rather than just keep it separate. So actually, Robert gave me an intro because the big thing on the block these days is systems, and networks in particular. So I think Robert, in two of his examples were system-based, and now you've got a situation in which very many areas. I mean, system reliability is one, which was mentioned. Tim, I know I once went to a wonderful talk by Tim on saying that reliability means you should be as far away as possible from the dangerous domain, which is a very systemic approach. You want to have robust systems, and you mustn't be near the kind of region in component space where they might fail, which I still remember that Emma's talk. And so we have topology, working with dynamics, working with stochastics, and we have concepts like robustness for systems, fitness for purpose, all kind of quality things here. We have design. We saw earlier in this workshop, we saw some very nice talks about sensor location for large systems, and I think most people, I say, put my hand up and say, this is a design problem. Where do you put the traffic sensors in the road network? So we have a major branch of experimental design, which is coming up over the hill, is let's say efficient data collection in the context of large systems. We already see it in reliability, but there's not that many papers on experimental design and reliability. Tim again has written some of it, so there's a huge area there coming up. And the role of statistics, well, in this, of course, I mentioned stochastics, we've got probability, so I have a bunch of people in our department, actually in my department, who work on random graphs. But they don't identify the random graphs, because they don't know how to. In fact, nobody knows how to identify, really, the transition probabilities or the stochastics of large systems. It's just unbelievably difficult. And right now in SAMSI, and we had a session on it earlier in this conference, where we're taking uncertainty quantification, which is something from engineering, polynomial chaos expansion. How do they talk to the Gaussian process people? And again, we're talking about big finite element systems. So there's big systems. And this is okay. So this week, actually two weeks ago, no, this week I think it was, there's a European call for big systems, but these big systems pointing towards policy. So if you think of the importance of all the systems we deal with, like infectious diseases, reliability, they're all, and global warming, which also has satellite observational, where do we put our satellites? I mean, important problems for experimental design. But what Europe's interested is in policy implications. It's no good just doing random graphs, running a big thing, measuring something on some hypothetical random network. These are real networks. I spent the lunchtime proofreading a project which I was kindly invited on, rolling out cities, rolling out green cities to the whole of Europe. And if there's nothing more, perhaps the most complicated network you would possibly have is a city with all the different transport and all the different links. One of the things that is happening, and we need to go on top with, certainly the people in computer experiments are beginning to think about, is these systems are modeled not with regressions or even Gaussian processes or even finite element, but discrete event simulations. Every car has its own intelligence and it has to operate in these big systems. Nobody knows how to identify them. Nobody knows how to observe them. Nobody knows basically. Even with Los Alamos spending years and years on traffic simulation, they really haven't got, to my understanding, really haven't got a handle. So coming to the main issue. So putting this experience sort of on the table, opportunities are to work in large teams. So the dream relationship for an academic statistician, particularly, is to be, a part of the product development team, right in there, a part of the planning team for a city, a part of the disease modelling team, not just somebody who's called in at the last minute when nobody. The worst thing is, you're a statistician. They think you can solve these people don't call you in early enough. They think you have the data too because you're a statistician, which is often not true. So get into the teams early, and on the other side, on the industrial side, please invite statisticians right into the team. That is the best way. And then there's all these very, very fine ways of interacting, and we don't want to list them. But I do want to say, as we have them here, I have EPSRC here, and we have Robert here. There are ways in which the government can help. I know it's not fashionable, but there are some barriers, and I'm talking about the B at the bottom, the barrier item. EPSRC in particular, the difficulty is, it's very simple. You get your company together, Rolls-Royce, you put them on the grant, you do everything right, and then the referee says, oh, it's so good, if the company likes it so much they can pay for it, and they reject the grant. So that's an absolute fundamental problem inside the relationship. Yeah, I think, I'm not being rude, I'm sure everyone's doing fine, but EPSRC paid lip service to some extent, at least up to a few years ago, acknowledgement. But this is follow through that we feel sometimes we're at a disadvantage when we do industrial calculation. When we get to the committee, the mathematician doing homological algebra gets a grant and we don't. So, and on the other side, then yes, this goes back to the thing about mathematics is also statistics. I'm very, very pleased to see two of the projects here have high statistical content.
Okay, so just start by telling you a little bit about how I've interacted with the industry, and this also kind of then covers sort of modes of collaboration as well, because I've done quite a few different types of things. So research contracts, consulting contracts with companies, and that's often a great way to start and try and build a relationship up. Which then can help you try and get into things like joint research grants, getting them on board with bids to research councils and things. PhD studentships, and that can either be through things like case awards or companies, it's quite rare, but occasionally companies will completely fund PhD studentships or more likely to partially fund. And in today's sort of economic climate, any money you can get in to sort of match against DTA funds or university funds is obviously a good thing to do. And quite key to all of these things is not just interacting with industry, but I think it's been mentioned by Claire, interacting with other subjects as well. So often you're going to have a much better chance with any of these types of things if you're going in there with a team, as Henry was talking about, so whether you're with chemists or engineers or what have you. And also talking to people at your own university or other universities, of course, helps you when you're then going and talking to people at GlaxoSmithKline, for example. If you know a little bit about how chemists talk, it's going to help you talk to the chemists at GSK. And also it helps to have a pet chemist on the phone. You can phone up and say, what the hell are these people talking about? So that's also quite useful. The other thing about these things is these don't, none of these things, or the majority of these things, have not been about vast amounts of money. So we're not necessarily talking large amounts of funding coming in, but what you are talking about are interesting problems. And that's probably one of the key things from an academic point of view. Certainly what I've found is the most interesting problems I've worked on from a statistical point of view have actually been problems that have come out of talking to either people in industry or people in other subject areas. So that's one of the advantages for academia. You get these new research problems. Nowadays, with the REF, the Research Excellence Framework, having an impact category in it, we have to worry more about how people use our research, and so that's another benefit of these interactions. And of course, you do get a little bit of money, which you can helps you to either build teams or maintain teams, funding PhD students or if you're lucky, postdocs. And of course, for industry, they get access to these new ideas. They get some element of sort of peer review and an external perspective of what they're doing, and hopefully they get some of their problems solved. So, the last slide basically covered all the different modes of collaboration, or at least the ones that I could think of. And what I would say is that often, and it's been talked about before, is trying to establish the relationship, but it's obviously crucial. And that means generally starting small and building up. And what certainly I found, and at Southampton we found very successful, is doing little bits of work here and there that you sort of use to build a relationship, to show that you can establish those contacts and sort of get your foot in the door, and you can then build on from there. Seems a bit negative to finish on barriers to success. I should have put these in a different order. But obviously, whenever you're talking to people from another discipline, there are problems of communication, of trying to work out what they're talking about, and they're trying to work out what you're talking about. And I have to admit, from my experience, generally, the onus is on the statistician to do that. You have to learn to talk their language. It's quite rare that they will make too much of an effort to learn to talk your language. And the other thing is, I think it's also been mentioned before, make sure expectations are very clear from both sides, so everyone knows what you're trying to do when you go into this collaboration. There's sort of quite firm ground rules there. And there's always this tension between sort of wanting to do research and the commercial pressures that the company might have. And this actually is just as much internal to the company, I think. Often, as an academic, you'll be talking to scientists in the company, and they're scientists. They want to do science. They're interested in these things. But of course, they have the commercial pressures from their managers above saying, well, you can't just, do whatever you want. It's got to be focused to a particular target. So trying to make sure that you can trade off those things and to come up with something that makes everyone happy can be sometimes difficult. Thank you.
Thank you. All right. Well, thank you to all the panel for this. I'd like to now throw it open, discussion open to the floor, and maybe one particular area that might be interesting to focus on, though of course you can ask about anything, but at some point maybe try and draw together some of these common themes that have been referred to that were coming through from today. But over to you, really. Questions for the panel, and yes?
Hi, just a bit of background. My name is Michael Hopkins. I've been running a consultancy specifically offering experimental design, best practice statistical modelling and optimization for about 18 years now. So I have a sort of view from the sharp end here about trying to sit astride the industry academic divide, if you like. I've just got some sort of random opinions that have come out from listening to some of the things you've been saying up there. First of all, this is really mainly aimed, I think, at Claire and Robert. It's probably aimed at the people who consider themselves to be the facilitators to allow this to become more, work better, if you like. Now, there is a classical divide here. On the one hand, you have the academic people have been producing some very clever ideas for maybe 50, 60 years about experimental design, and they would be very valuable in many different industries. Unfortunately, many of them are not well understood, whether that's because the academics don't express them very well or don't express the benefits very well, or whether it's because the industrial users don't understand the benefits very well or are not looking in the right direction, I'm not sure. But there's a chasm there sometimes between best practice ideas, best practice techniques, and what they would be useful for. There's absolutely no question in my mind that these ideas should be used more widely by many different industries and very many different sectors. It has been frustrating over the years. It's not always easy to get people to see the benefits. Typically, to get a really good collaboration working, I've had a few over the years with lots of repeat work and lots of benefits which grow within the company. You have to have someone within the company who understands the benefits and is prepared to put some money behind it and to get some management buy-in to the benefits so that it can flourish within the company. If you do one or two good projects which have good results, if it's not supported by upper management, it'll wither on the vine. So there has to be some support within the company. Now, sometimes there's not a great deal of trust. Some consultants have a bad name. You pay too much to offer very little. In general, that's not true, but in some areas it is true. But not, I think, in this area is where you can really offer big benefits to a company, both in terms of research opportunities, improved profits, all the things that companies want. DOE offers all that. Best practice DOE offers all that. But that means using the best ideas which are out there and applying them intelligently. What Dave was just saying at the end there is very true. You have to, statistician has to, I have an engineering background before I became a consultant in statistics. You have to be able to talk to the people and communicate well with the subject area experts. Otherwise, it's not going to go anywhere. And that's a skill that maybe academic statisticians have to learn better, I think. They have to be able to discuss the real issues in the right way. I wonder, potentially, whether there's any mileage in having a central... The facilitators here, government facilitators, this is a catch-all term, it seems to be a case of trying to put people in touch with other people, like a networking, and a lot of practices and networks and things to allow that. I wonder if a more old-fashioned idea of a central department which offers best practice expertise would be a good idea, in the sense that people could come to you and they would trust that department because it's best practice, it's expertise, it's academics or people with a lot of background, and it could then be offered, I don't know, from within government or within some body of the government to be offered to industrial clients or people who want to use these ideas. I wonder if that might bridge the trust gap and the communication gap, because part of my problem over the years has been, I'm not a marketing man or a businessman particularly, I'm an expert in my area, if you like, but you have to be more than that to run an effective business and get lots of work. So if someone else could be, if there could be a central department in some way which offers these ideas, where it is best practice and they're sort of accepted experts in the area, I think we get a lot more buy-in to it from big industrial clients. I'm not sure, that's an old-fashioned idea which maybe isn't fashionable anymore, but I think there might be some mileage in that which might remove some of the problems in the area.
I think that's a great idea. At the moment in GSK, we're essentially attempting to put that into place, and it's a hell of a problem because you've got, within GSK, you've got 96,000 employees, and how do you actually manage that, and how do you get people to agree what best practice is? So I think the concept is really good, and I think it's something we should strive to do. I think the challenges involved in that are considerable. And I think part of the thing that we're doing with Southampton, the postdoc we're doing in Southampton, is an enabler to actually help us put that together within GlaxoSmithKline. How you actually get, I think one of the challenges I have with the funding issue is that to actually get government funding, one of the ways to increase your chances of doing that is to go in with the consortium. And my experience is that going in with consortiums are fraught with difficulty in terms of building the consensus. So I think it's a great concept, but I just think working on ways to do that is really important.
I would say it's not so much a role for the research councils, perhaps the learned societies, if you're talking about a best practice, formulating best practice, because our kind of remit, if you like, is to fund new research. So we're kind of the next generation on, whereas I think what you're talking about is understanding the methods that are already out there, and so people can apply them consistently and know what they're doing. So I would say possibly perhaps that's more of a role for learner societies or somebody else.
Do you feel that the people in fundamental research who are moving these things forward understand the benefits of DOE well enough and statistical modelling and all the stuff that we're talking about today? Do you think they have to be sort of pushed into it, or there has? My feeling certainly has been over the years that you have to have someone within the organisation who understands the benefits and is prepared to stand behind it for it to flower. And
Within
often
a
that isn't the
company.
case. Within whether the organisation that's doing the research or whatever they're doing, the industrial partner, the industrial side. And it's not common for people. It's almost like, because of all the issues we talked about privately earlier about education and such, there's often not much statistical teaching on specialist courses, chemical and mechanical engineering. It's spotty. The knowledge of probability theory and statistics in those areas is
Really
not
didn't as fancy as probability theory, do you?
But I just want to tell a little story. So this, it's not me boasting, it's what I've been doing. It was fresh in my mind. Rolling out green cities to the whole of Europe. So I thought, I'm going to ask my colleagues at LSE. So the other area I knew where they roll out best practice is the health service. So I emailed Gwyn Bevan, who's an expert on the health, as a professor. So tell me everything about rolling out. You have 5 minutes to tell me everything about rolling out best practice in medicine. Right? So they do have these institutes. I know something about them. Rolling out, for example, how to keep the hospitals clean, surgical practice, just simple things which actually save lives. He wrote back saying, try this, brackets, they just closed the institute down, or something like that. So it is a political issue. I think it's a fantastic idea to have central organisations rolling out that best practice. Europe loves it. And I'm not playing politics here, but it's not clear that the environment now for doing this in the present government, well, we can always change. Robert will say it.
I mean, first of all, Michael, I think I agree with pretty much everything you said, without exception. The question about whether there's some sort of hub that can kind of act as a concentrator, or I think is what you're alluding to. And there are two ways of doing that. One is to act as a hub that that companies could go to gather best practice. And actually, I think that's perhaps not so easy to do because it's difficult to keep that hub up to date. And certainly in a lot of branches of mathematics, you've got lots of pockets of excellence that are really heavily distributed. And mathematicians, and I'm including statisticians when I say mathematicians, I hope you're not. It just saves time. They're very mobile. They're not tied to large laboratory facilities. They move institution fairly frequently, especially when talented young researchers move institution very frequently. I think having a hub that can kind of gather expertise like that is quite hard. What we've found works quite well is to do it almost the other way round, so that companies can come to us and say, I've got a problem in X, Y, and Z. Can you put me in touch with some people who've got some good ideas? And we maintain quite a close circle of leading academics, about 30 of them, and they in turn have links out into their own institutions and research groups. So we like a two-tier network where very quickly we can put out feelers and gather contacts where research is developing, because very often the best ideas or the leading ideas or the relevant ideas are not the ones that have appeared in print yet.
Absolutely right.
And so you kind of got to get to the people. It's not enough just to have some sort of pile of best practice documents on your shelf. You've got to have
people who are
connection to the people.
active collaborators and researchers.
Yeah.
But they're always going to be keeping their skills up to date anyway. In my experience, you have
Yes.
to, otherwise you can't
Yes.
compete.
Yeah.
You can't offer the latest
Yeah.
things if you're
Yes.
not doing the latest research. So I don't see it as a monolithic thing that's set in stone. I see it as a living department. You have these in industries. You have research departments which are always evolving and improving. And that's a sort of research department. But you could also have that as a quasi-government department, if you like,
I think
with
there's
researchers.
a very interesting point. But could we kind of continue this over a glass of wine
sorry.
this night?
Sure.
And so we've got time to discuss anything else on people's minds.
I have a question to Keith here.
Could you just speak up a little bit?
Sure. Okay, so Southampton is a very proactive institution. They went on the institution level, made this contact. Their PhD students are really lucky because they have something already made. The contact is made, you have approached the company, right? So it's a working collaboration. But there are some PhD students who are not, the institution has not, set up anything. So what's your advice to such PhD students? How does a mathematics PhD student in the current climate keep themselves from being unemployed?
Keep themselves from being unemployed.
Yeah. So make
Could,
themselves
could you
useful
repeat
to-
the question? We can't hear anything at the back.
Would you like to just stand up and tell the people at the back?
The question was, how does a mathematics PhD student keep themselves from being unemployed?
Yeah, so useful things, maybe you have some useful knowledge, you want to be useful, but...
And in particular, when there isn't a kind of project set up that's already got some, industrial experience built
Absolutely,
into it.
but in this case, you see, in Southampton's case, the project is set up on the institution level. In other words, you come in as a...
And that's true of lots of other
There's
places,
an
let me
existing-
quickly add.
Yeah.
Okay.
There are other universities.
Yes, right. Embarrassing. Right.
Well, yes, it's a
I-
bit of
so-
a flip side, isn't it?
There is a sort of risk. The sort of risk is when you do a PhD, you become an expert in something that's extremely narrow. And so, if you recognise that when you go out beyond that sort of milestone of picking up your PhD certificate, that actually the world's a bit broader than you've been living for the last 3.5, 4 years. One of the things we've done with the projects I showed you, there's an online group where students can register and they receive email alerts whenever there's a new expression of interest from a company who comes in. So any student anywhere who wants to, any PhD student who wants to work with a company and see some opportunities for doing that, go
You
to our
would
website
literally
and
get an
register.
email saying there's a problem such and such, would you like to apply for it?
When a company, how we run these companies write to us, say, I've got a problem, here's a 1-paragraph description, I think it would suit a student who has these sorts of skills. You can get an email.
Can
alert
this
whenever.
list be accessed from your website at the moment?
Yeah, I can.
Yeah.
I mean, if you wanted to, I could certainly. You can just go register for it, and then you get automatic updates.
Just a very quick answer. Your other departments in your university, so your mathematicians may not have links to outside world to help you get jobs, but they should have links to engineering, to biology, and so it might be 2 stages. You first contact the engineers have links to Rolls-Royce. So when I was at City, Engineering Design Centre, we had huge links with engineering, joint PhD students. I didn't go straight to industry, I went via the engineering.
The good thing about your KTN scheme for PhD students, and something that worried me when I first saw it, I thought, oh dear, they may only have 3 years to do this PhD. They're going to walk away for 3 months, as a supervisor, you'd be a bit worried about that. But in fact, the kind of PhD is suspended, you don't lose that time. That's correct, isn't it?
Well, you maintain your student status,
Yes.
but you don't lose any time for
support.
what you were doing
Yeah.
in the first place.
But we shouldn't forget doing it the other way around.
I think that's
Yes.
fantastic. when you go forward with that.
I think, it's easy for me to say it now, I've done it. In fact, I met a lot of people in industry that did the PhD the way around I did it. The best thing that ever happened to me was I didn't get a first, because if I'd have got a first, I would have done a PhD at Aberystwyth and probably stayed there. Not that there was a problem with staying in Aberystwyth, in fact, I was back there last month. I knew I wanted to work in industry, and I knew that I wanted to do more with statistics. And yes, I was lucky because I happened to have a boss that had done his PhD that way. There were other people in Dunlop who I got to know who also did their PhD that way. So I actually did get a little bit of prior knowledge on the 8-year thing. But it was a fantastic way to do it, actually. And it's tough, but it does create a different dynamic, and you certainly get an interesting perspective on the way you develop academically, while at the same time you're pursuing your career in industry. And just one other point to Henry's, I completely agree with Henry that where it's fun is where you get involved in product development. And my career culminated actually in Ford and then Jaguar Land Rover in very senior jobs where I was directly influencing the way we did product development. And it is fantastic fun.
And any more points, different topics from the floor? Yes?
So one thing we're seeing in chemistry is
PhDs being turned around, so reverse PhDs where industry chooses the topic of the PhD. The student spends the bulk of their time in industry and only goes out to academia for a short period. This works really well for chemistry. You get a good range of experience and you learn good business skills. Do you see that working in the mathematics environment? I mean, one thing that's been held up against, say, our postdoc working in industry for a long time is they're not getting the depth of research that they would if they were in an academic institution. But they are getting business skills and they are increasing their employability at the same time. How do you balance those two things?
Just a quickie, it's very important that if they do that, they come back into the university for research training. Now, let me compliment EPSRC. A wonderful series of doctoral training programs now in mathematics, including statistics. We have a big one in London, there's one also in several of them in the country. I mean, you should be going in, they should release you to come on these training programs. So you might take a subject like functional analysis or something you don't know about. It's important you don't just do training on what you know about or what's relevant to the job. You need to be back in the university to get that training as well as supervision.
Can I pass a comment on that? I know I'm the chair, but forgive me. But I can see it would work terrifically well with chemists because often, from what I've seen, industry has far better equipment than university chemistry departments. You know, real state-of-the-art stuff on your robots, you know, they give their right arm for them in some departments of chemistry. I think it's a bit more problematic in a PhD in statistics where there is a large mathematical development to be done. I think then that the student needs to spend quite a lot of time working on that at the institution in close contact, not just with their regular supervisor, but with other similarly working research students and staff. And although it's a bit tempting, I would be anxious about shortcutting that. So, you know, I think you can, but it's a great idea to have the student getting the experience in the company, but you don't want to squeeze down on the essential time for developing the new ideas.
I would agree with that, I think. I'd be a bit worried about the level of support they might get. And there's also the tension between what constitutes a PhD and what the company might want to do. So you have to be aware that at the end of the day, the PhD student after 3 or 4 years has to have produced, you know, the scary thing of something new. And there's a danger of how well you'll be able to do that if you were just reacting to the company's problem.
I think that problem is somewhat dealt with if you look at it the other way around, and if the student is an employee of the company. I mean, that's a different way to do it.
I think we've been rather poor when you look at overseas. We've been rather poor in the UK about having people go through the experience that Tim's gone through, where you're based in a company and you move into a university for an extended 8 years might be more extended than you bargained for, but for an extended period.
I'm not very bright, so maybe, maybe you could do it in 6. I think if you look overseas, this sort of movement of people happens much more frequently and at more senior levels too than PhD students. And it's something that we don't see very much of in the UK.
Just a quick on that. I mean, again, I'd like to talk about what I've been doing recently. So 2 weeks ago, I was externally examined for a PhD, and I have an invitation. It was a big PhD in a sanité in France with Olivier Roustan, who's the group there. So we talked about these very issues. So there they have funded master's programs, 2 years master's program. You set up a link with the company, you carry on and do a PhD with the company. They give you a job after that if you don't want to be an academic. So absolutely agree that my experience, which is quite considerable actually, in Holland and in Norway and a little bit in France, much better structural funding of the link between universities and industry, with real employment channels going straight from third year, fourth year undergraduate, straight through a master's, PhD if you could, right out in industry. And they populate industry with extremely well qualified people as a result. I think there's a big gap in this country. Hopefully, again, you guys are trying to fill it, but
I think the opportunities are there. It's making people aware of them and people taking them up. So there's case studentships, for example, where the student spends
Good
So
balance, yes.
it also, of course, depends very much on the company and what the environment within the company is like. All our doctoral training grants we give to universities, we've asked universities to aim for 10% of those to become case-like studentships. And then when you go higher up, when people apply for postdocs, they can spend a certain amount of time in industry, and that's an eligible cost of the grant for them to go back into the course of the company. There are Royal Society industry fellowships to allow people to spend time in industry, or industry people to spend time in academia, and vice versa. So the opportunities are there. It's how we make them generally known, and then how we encourage people to take up those opportunities. And then, of course, the more people do it, it sort of sets the ball rolling, because people see somebody else doing it and they realise the benefits. So I think it's also about sort of pushing these opportunities and being a bit proactive.
Yes.
I just want to carry on with this subject, because I agree very strongly with Tim's point about having the experience in industry and sort of simultaneously doing the academic aspect of it. I think the problem is, although I did that myself also, is that, and I think maybe the difference with something like chemistry is chemistry departments are big. Statistics departments in industry, even a big company like Pfizer, is relatively small, and it's a big overhead to have somebody who's essentially learning as an apprentice. So you need a special sort of person like you, Tim, to be able to carry that off, I think, successfully.
I just had very good, I mean, it wasn't me that was special. I was just very lucky that I had far-sighted bosses.
Well, it's both those things. Yeah. So, yeah, again, I'm very lucky as well. You have
the environment within which I.
But it's not just that. I mean, you need to have someone who is very self-motivated, who can hit the ground running pretty quickly, because they need a lot of mentoring. And the other problem is in industry now, there's not as much money to do this sort of thing. I'm thinking back to the 80s, probably the same as you, when I was doing this. I think how generous Rolls-Royce, who did it for me, were. I can't imagine companies being that generous nowadays. And those two things make it very difficult, even though I think if we could find the money somehow, and I think industry have got to find it.
But engineers do a lot of this. I mean, if I think back to my time at Jaguar Land Rover, I mean, I could give you the name of 20 engineers that did their PhD the way I did mine.
They're bigger departments, aren't they, Tim?
Well, they are, but I mean, but
they can carry that.
But
that's the thing.
It's doable.
Yeah, it's very difficult when you've got like 6 statisticians and one of them is, and then someone's got to mentor them, and it's a big overhead.
Okay, well, maybe this is something else that would benefit from a drink, I think. So let me thank the members of the panel very much.